So the essential question, how do we find the best fitting line equation to a set of data? We're going to start with some definitions, kind of answering some of those discussion questions that we did in class. And then we'll get into an example where we'll actually start doing this, okay, and fitting that line to that data. And you'll find it's very similar to what you guys came up with on your own working in your groups, okay? So our scatter plot. So it's a graph used to determine whether there is a relationship between paired data. So there is some data that you will look at and it's not going to look linear. Okay, the activity that you graphed, that data looked fairly linear. Okay, it followed a straight line pattern. There's a little scatter around the line, but it was in a straight line pattern. Not all data is like that. You're actually going to see an example on your homework assignment of data that's not linear, that's not a straight line. So you make the scatter plot to see what the shape of the data is to start with. Correlation. This is a description of how the two variables are related. It gives you direction and strength. We're going to pretty much only look at direction in this class. So direction would be, is it a positive slope, a negative slope, or is it so scattered that it doesn't even look like a straight line that there would be any slope? Okay. The strength part is actually a number that says how close it is to a straight line. So your scatter plots were much closer to a straight line than my scatter plot. My scatter plot is a little more spread out up here. This one would have a smaller number than the one you guys have. But we don't have to worry about the number piece. We're just worried about, is it positive, is it negative, or does it not look like there's any correlation? So this is going to be our area of focus right there. These are a couple of descriptions. So if it is a positive correlation, like the one that you did in your activity, if it's a positive correlation, then y tends to increase as x is increasing. So if you look at your graphs and you go along the x-axis and you kind of follow your graph as you go, as the x's are getting bigger, the y's are getting bigger. Okay, it's going up. That's your positive slope, your positive correlation. A negative correlation is that the y tends to decrease as x is increasing. So x is always increasing. You always look at the x as an increasing value. And then you see what's happening to the y. Is it going up or is it going down? So that would be a negative correlation. The y decreases as x increases. And then the relatively no correlation, and that's when you look at x and y and you look at your scatter plot and it's so scattered you can't tell whether it's going up or going down, whether it's positive or negative. It's just a whole bunch of dots. Okay, that would be relatively no correlation. Line of fit. Okay, so this is what a lot of you guys were having trouble with when you had to come up with your own definition. What did you think it was? So this is our official definition. A line of fit is used to model trend in data. Okay, if it has a positive or negative correlation and a linear relationship. The line of fit describes that data. Okay, I like how many of you wrote your explanations of line of fit where you were saying going right through the middle where you have some points on top, some points on bottom. Okay, and going right through the middle of your data. Make sure your points are as close as possible to that line when you do it. Okay, so right through the middle with all the points really close. So that would be your line of fit. To describe correlation, so one of the questions I'm going to ask you on your test is to describe the correlation of your scatter plot. There are two parts that you need when you describe the correlation of your scatter plot. The first is the basic general type. Is it positive, is it negative, or is there relatively no correlation? Okay? Positive, negative, or really none. So that's the first part, telling me which type. The second piece is where there's a little more writing involved. So you have to then write what the meaning of the correlation is in context. Okay, what's the meaning? So that would mean like the y increases as x increases, or y decreases as x increases, or there's no relationship between x and y. Now, you're not going to use these phrases exactly as you see them, because it says in context. So in context, you need to include what the x and the y represent. So remember the height and arm span example from our activity. The way we would write it in context, okay, the way I would write it in context, well, let me do both parts. So it would be positive correlation. That's the first part. That's our number one. And then the number two, as the height increases, the arm span also increases. Okay, so that's how you would write it. So you're going to put in the context. Instead of an x and a y, you're going to see what it represents. Height and arm span. Okay, so I put the words in place of the letters so we know what it represents. That's how you would answer the question about correlation. All right, so these are some notes, I think, things to remember, kind of a guide to doing it, and then I think I have an example on the next page. All right, so let's see. To determine if a set of data can be modeled by a linear equation, it must appear to have a linear pattern, positively or negatively correlated. So this is our first thing. So first, and you can shorten this, your scatter plot must look linear, is basically what that says. Okay? It has to first look linear before you can do any of the other stuff we're going to do. So that's why we make our scatter plot first. We have to see what it looks like. Once it looks linear, then you can write an equation that models the positive or negative correlation between the two variables. So basically, you can write an equation. If it's linear, you can pick 2 points on your line and write your equation. Oh, this was a big thing. So this kind of explains how we write that equation. So these next steps explain how we write that equation. So first you would draw a line of fit on the graph. So you can say draw a line of fit. Use 2 points on the line. They can either be from your data, but they have to be on the line, or they can be 2 other points on the line. Okay, they don't have to be points that are in your data table. Any point that is on the line, you just need 2 points that are on your line. Okay, either from the data itself or other numbers within that data range, as long as they're on the line. And that answers some other questions. Some students were wanting to use points that were not within the data range. You can only use numbers in the data range. So whatever your smallest data value is and your largest data value is, you can only use numbers between those numbers. You can't go outside those numbers. Okay, so stay within your data range. This if possible but not necessary piece, that's referring to the data part. Okay, 2 points from the data, if possible, because they're easy, they're already there. But if not, then you have to do 2 other points, okay, as long as they're on your line. And then you use one of our old formulas or formats. We tend to use this one more often. Okay, it's the most popular one to use. The one you'll probably use most in later classes, the slope-intercept. But you could use point-slope. Just make sure your final answer is always in this format. Okay? So then you use one of those 2 formats to get your equation. And we always want the equation at the very end to be y equals. Always have to have the y by itself. Next slide, I think, has an example, so we can do one. So the scatter plot here is already done, all right? And it is a scatter plot, I believe, that's in your book. So after we go through the example, I'll look it up so you can write the page number and refer back to the scatter plot. What I've done, though, is write questions like I would write them on a test. Okay, so this would be one problem. I would ask you to make a scatter plot. Okay, and I know you guys can do that. There were a couple of us that needed to, some work on it, but you'll have some work on your homework, some practice with the scatter plots. It takes a while to make the scatter plots, so I didn't want to spend a lot of time on that right now. So you're going to make your scatter plot. This is minutes on a treadmill and ounces of water in your water bottle. Okay, so if you're sitting on the treadmill, you got your water bottle up there. The longer you're on the treadmill, the more water you're probably drinking because you're sweating, you're using up that energy, getting thirsty. Okay, then it says describe the correlation. So remember, there's two parts. So what's the first part? We want to know, is it positive or negative? Everybody said negative. Correlation. That's the first part. Now you need to describe it in context. It was negative. I always like to start with the x, even though my examples in the notes start with the y, but you could do it either way. So you can put the x first and then the y, or the y first then the x. You just have to be careful where increase and decrease go, where those words go. So as the minutes, or you could say time actually kind of sounds better, on the treadmill increases, the ounces of water in water bottle decreases because it goes downhill. Okay? That would be the in context. So you're using the words of x and y to describe what it means. All right, let me get a copy of this. So we can still see it when we do part B. So draw a best fit line on your scatter plot. So would that be a good line? No. All right, so whoops. Undo. Okay. That'd be a good line? No. It goes through the middle of the data, but those data points are not very close to the line. It doesn't seem to go the same direction, right? Okay, different direction. How about that one? That one better? Okay, maybe move it that way a little. Okay, something like that. Now, you guys are just eyeballing it. There is a way to calculate. It gets more complicated, and we usually do it with technology. I have my AP Stats do it with technology and by hand. There is a way to get a best fit line that gets those points as close as possible to that line. You guys just have to eyeball it and get something that is reasonable, okay? A reasonable line of fit. So that means everybody's answers are going to be a little different, okay? Which means the communication is going to have to be very clear about what points you're using, and I'm going to check, are they on your line? Okay, it's going to be very important that everything matches up. So here, so we drew a line of fit. Now we want to write an equation. So what do I need to get to write my equation? Yeah, I need 2 points to get my slope. So let's see, this point looks pretty good. This point looks pretty good. Let me see if I can figure out what those points are. Okay, so this is 25 and 7. And 45 and 2? 1. Oh, yeah, it goes by 2. Okay, so 45 and 1. All right? Okay. So now you find your slope. Okay, everything else here is just the same as what we did in standard 6. So 1 minus 7, 45 minus 25, negative 6, 20. Simplify as much as possible. Divide by 2. So that would be what, negative 0.3? I don't know how I keep getting them looking nice. That's actually not a bad one. Negative 3/10. You could leave it this way, which is the same as negative 0.3, right? So you can leave it as a decimal also. Decimals are most of the time going to be nicer. Y equals negative 0.3x plus b. So pick a point. I'm going to use this one. So 1 for the y, negative 0.3 times 45 plus b. What do we get when we multiply that? There we go. Add the 13 to both sides. So that'd be 14.5 is b. b equals 14.5. Write your final equation. Y equals negative 0.3x plus 14.5. There's my equation. Okay. Make sure you identify that your x is the minutes on the treadmill and the y is the number of ounces of water. Okay. I just have one more part, our prediction. Okay. And how we would use our equation. So that would be the last kind of question I ask. Now that you've got an equation, the whole point to doing this is so that we can make predictions. So let's predict a reasonable amount of water left in the water bottle after 27 minutes on the treadmill. So what am I going to do with the 27? Plug it into your equation. That was the whole point, to get the equation so that we can use it. So y equals negative 0.3 times 27 plus 14.5. So what do I get when I multiply 0.3 times 27? 8.1. Now be very careful with your positives and negatives. They're going to be very important, okay? Because we have to subtract these two numbers to get your correct prediction. So y is equal to 6.4 ounces. You can use the graph to double check, make sure you did it right. 27, it's about right here. Go to your line. Does that make sense, about 6.4? Yeah, it makes sense. That's 6. It's a little above that, so we're good. Okay, so the graph is a good way to double check. Make sure it works. All right, any questions? I know we're close to the end there. Your homework is a handout. Okay, first one, you're just telling me what kind of correlation, positive, negative, or no correlation. That's it. That's all you're doing for the top. The middle, you're going to scatter plot, make a scatter plot, and then describe what you see. And they'll ask some questions there. These two, 3 and 4, are exactly like what we just did here. So you're going to read the questions. There's a couple of extra think beyond kind of questions, but most of the questions are exactly like what we had right here. Okay? So it'll help you do those two questions. So you have to make scatter plots and then answer the questions, describe correlation, and things like that. So let me get these passed out.